Thank you for joining me. So today we're talking about displaying quantitative data with graphs. So in this video, our learning targets for the day. I can construct and interpret a dot plot or stem plot. I can describe the shape, center, and spread of a distribution. I can identify major departures from the pattern of a distribution, or talking about outliers. So the first thing I want to talk about is just simply how do you construct a dot plot and a stem plot. All right, so now right here, I have step-by-step instructions. I'm not going to read through them verbatim because you're going to get those instructions as I'm making your examples. Just in case you get lost in the process, it is a place you can go to look to see why am I doing what I'm doing. So to make a dot plot, so here's data on a 20-point quiz that 19 students took for Algebra 2. All right, so to make a dot plot, the first thing is you're going to make a horizontal axis, okay? And you need to start at the smallest value. So here, 5. Now notice I don't have to start at 0 when I'm making a dot plot, okay? So kind of a nice feature. Now I'm going to go and I need to work my way up to 20. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I need to make sure that my dot plot spans from the smallest to the largest value. And now I just start putting the values on. So I have a 5, I have a 6, I have a 14, I have two 15s, I have two 16s, I have three 17s, two 18s, three 19s, and four 20s. Then, of course, you want your label. So dot plots are really easy to make, okay? It's a really quick graphical representation of quantitative data, okay? The other one I'm going to show you is a stem and leaf plot, okay? Or here they just call them stem plots. So the first thing that I notice is I'm dealing with two-digit numbers, okay? So what I'm going to do is I'm going to split it into stems and leaves, okay? So here I'm looking at single digits, teens, and in the 20s. So that's what goes on the left-hand side, is the stem. So the 0 is going to represent any single digit. So then the 5 and the 6 come over here. The 1 represents, it represents the teens. So I put a 4 here to represent 14. 5s to represent the 15s. 6s to represent the 16s, 7s to represent the 17s, 8s to represent the 18s, 9s to represent the 19s, and now for 20, well now I just put a 0 to represent those 20s, okay? So in this case, my stem represents the tens place. My leaves represent the ones place, the unit digit. Okay. Now another thing here is we need to make sure people know what this means. So here, when these say a 1, 4, I need to tell them that that represents 14. Because it could also represent 1.4 or something like that. You don't know unless you put a key there to help. Okay? So, stem plot. And again, title, you could put score as your title. Okay? But for stem and leaf plot, one of the biggest things is make sure that you include that key so people understand what those numbers exactly represent. So now that we know how to make those two types of graphs, now let's talk about how to describe the graphs. Now, quantitative data. We have 4 things that we can describe, okay? Now, I like to use the acronym SOX for describing quantitative data, okay? And this is going to go through the entirety of the course. Whenever they ask you to describe quantitative data, no matter where it is, in AP Stats, no matter what chapter it's in, they're looking for 4 major things, okay? The first S represents shape. So there's 3 main shapes that we're going to talk about, okay? The 3 main shapes are symmetric. So notice that just makes a nice shape like that. This is called skewed left because notice there's a tail over here. So notice in these descriptions, the description is describing where the tail is. And I even put this on here. So skewed right is going to look like this. It's going to trail off towards the right. So do make sure that you remember in these descriptions, when you're describing the shape, if you do skewed left or skewed right, you're describing where the tail is going off to, okay? Where is it trailing off to? All right, and again, most commonly, those are the 3 main ones. But you can also talk about unimodal versus bimodal if you want an additional description of shape. Unimodal means like that. Bimodal would be something that has 2 peaks, okay? And that peak, if you recall, I don't know what grade you probably learned this in, but that's the mode where most of the data is, okay? The most concentrate, like the most common value of the data is where the peak is, so that is the mode. The O is talking about outliers. This describes any strange points that are in the data, okay? So strange points, so let's say my data looks like this. Then all of a sudden, I have a point way out here. This would be a potential outlier, okay? In section 1.3, we're going to talk about exactly how to calculate outliers. So for now, I just will probably use the term, this is a potential outlier, okay? Using kind of soft language until we can show the calculations to support what we're saying. But again, all an outlier is just a unique data point that doesn't follow the rest of the pattern, okay? Center. So there's a couple measures of center. The one we're going to talk about today is the median. The median is the exact middle of the data, okay? So where 50% is above it, 50% is below it. So when the numbers are in order and you're looking for the median, for odd numbered data, it's just exactly that middle center value, okay? And I know in your note packet, I caught it right before I started making the video, I mislabeled odd versus even, so make sure to scratch that off and write the right one in your packet, okay? So the median for odd data is the exact middle. For even amounts of data, so here, notice, the center is in between those two. So I have 6 data points is in between the third and the fourth data point. So what you do is you just average those two numbers. Okay, so 46 plus 61 divided by 2. So the median for that one would be 53.3. So of course it's always easier when it's the actual center of the data. If there's an odd amount of data. When there's an even, just average the two around it. So here notice when there's 5 data points, it's the third value, so half rounded up. When it's even, it's in between the half point or the halfway point and then one above it, okay? I will do more with that throughout the course so you're comfortable finding median when it comes to larger amounts of data, when it's harder to just count up, okay? And spread, note the minimum and the maximum values of the distribution or the range. So for our quizzes, it ranged from 5 up to 20. That's a description of the range, okay, or a description of the spread, okay? So those are the 4 things. So again, anytime you're asked to describe quantitative data, think SOX. SOX is how you're going to accurately describe the data, or fully describe it, I should say. All right, so let's talk about this. So the dot plot below displays the Environmental Protection Agency's estimates of highway gas mileage. Sorry about that. Gas mileage in miles per gallon for 24 models of 2009 mid-size cars. Describe the data. So they're asking us to describe quantitative data. We're going to use SOX. Now what I recommend is writing out SOCS, kind of sketching out what your answers are, and then writing complete sentences about it. Okay? So, S for shape. Okay, the shape, I'm seeing a lot of data on the right, and then it looks like it's trailing off to the left. So I'm going to say this is skewed left. Outliers. Okay, so it looks like most of the data is between 22 and 33. Then we have 2 values that are pretty low compared to the others. So I'm going to say potential outliers at 14 and 18. Again, I use potential because they don't quite fit the pattern like the rest of them, but we don't know for sure if they're an outlier. There is going to be a way to calculate this. We're just not doing it yet today. Center. So for center, we're going to be talking about the median. Well, let's think about this. So 24 models. Okay, so remember when we had an even amount, it was in between the halfway point and the next one. So half of 24 is going to be 12 and 13. Okay, so because it's an even amount, it's going to be in between the 12th and 13th data point. So what am I going on about here? What am I talking about? Well, what I'm talking about is in order, I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so there are, in order, the 12th and 13th data points. Okay, and the center is going to be the average between those 2 values. Well, in this case, the 2 values are the same number. So what that means is the center really is just at 28. All right, so that's how you do it for larger amounts of data. That's what I was trying to get at before of, oh, I know I have 24 data points. Well, line them up in a row. I know the center is between the 12th and 13th data points. And then the spread is from 14 up to 33. All right, so now that I've labeled this out in socks, now remember, whenever giving a description, I need full sentences. So now I'm going to write out in full sentences, the distribution of highway mileage is skewed left with center of 28 miles per gallon, a range of, and then here I showed my calculation, 33 minus 14 is 19 miles per gallon. 14 miles per gallon and 18 miles per gallon are potential outliers. So here I took it a step further. I also showed what the range actually was, okay, the difference between the min up to the max. All right. Notice though that I did all my scratch work, then I went and put it in complete sentences. All right, that's going to be key that you write full sentences, complete thoughts. All right, for our next example, well, in our next example, we're talking about making comparisons, okay? Below are two samples of 50 household sizes for the UK and South Africa. Compare the distributions. When we're making comparisons, okay, comparisons, you can't just list out all of the numbers, okay? They don't let that count. You will not get credit for making comparisons unless you use comparison words. So that's what that AP exam tip on top is trying to say. You have to explicitly compare values with words like greater than, less than, about the same. You can't just list what the numbers are, you have to explicitly compare the numbers, okay? So make sure you remember that because that's very easy to do, okay? But if you forget, you're going to lose very, very easy points. All right, so making these comparisons. So just like before, I'm labeling out socks and I'm going to go through, just do some scratch work before I write down in full sentences and complete thoughts, okay? So, shape. Well, the shape of the South African ones, it looks like the bulk is to the left and it's trailing off right. For the UK, and here I'll label, I'm doing South Africa in blue, I'll do UK in green. All right, for the UK, there's no trailing off exactly. So this is where it gets a little bit iffy, and I know some students have some frustration of, it's not perfect, but this kind of just looks roughly symmetric to me. Okay, because there's no dots out here or anything like that trailing off. They're condensed and for the most part pretty symmetric looking. So again, notice my soft language, I use roughly symmetric. It's not exactly symmetric, but it's close enough. Okay, so O for outliers. Well, I see potential outliers here and here. And that looks like it's approximately 15 and approximately, what, 25 or 26. And then the UK doesn't really look like it has any potential outliers. Okay, so I'm just going to say, you know, there really aren't any there. Center. Center, well, this time there are 50 data points here. Okay, so 50, that's an even number, so it means it's going to be in between the halfway point and then the next data point. So what this means is as I'm counting up, it's going to be between the 25th and 26th data points that I count. All right, so let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26. So it's going to be between those two right there. And so that looks like it is at 6, okay? Well, I'm sorry, that should be in blue. And the median is at 6 members per household, Okay, again, when they're the same, when they turn out to be the same value, both of those data points have a value of 6, but then the median is clearly 6. For the UK, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25, 26. So the UK is centered at 5, okay? A little bit smaller. For spread, okay, so for South Africa, we're talking about 25 or 26. Oh, sorry. 25 or 26 down to, that looks like 5, 4, 3. And the UK is going just from 6 to 3. Or down to 2, sorry. It's a tiny graph, so sometimes it's hard to read. All right, so there we have it. We have all of our kind of scratch work done. So now let's start diving into the actual comparison. Oh, sorry about that. The actual comparison. So the distribution for household size in South Africa is skewed right, whereas the UK is roughly symmetric. The center for South America is 5 or 6 people, which is greater than UK, which is, they say, about 4 people. And again, we found the exact amounts, but we could tell that it's less. It looks like the book that I got this from was kind of free-handing it. The range for South Africa is much greater than the UK. South Africa appears to have 2 outliers, a 15, oh, they say 27, but there are no outliers in the UK. All right, so again, I just want you to notice that that you're making explicit comparisons, right? Greater than, less than, about the same. You're using your comparing words, okay? That's going to be the absolute key here when you're doing these. All right, which gender is taller, male or female? It's a sample of 14-year-olds from the United Kingdom was randomly selected using the Census at School website. Okay, so here they've already provided a stem and leaf plot for us, okay? Now what I want you to see is the difference between something called stem splitting, okay? What stem splitting is a look at this right here. There's 2 stems of 15, okay? So what this means is I'm splitting up. The top one is where the 151 and 154 go. The bottom one is 157 and 159 for the stem and leaf plots. Okay? So what I'm doing is I'm splitting it up. So this top one is taking 0 through 4. This bottom one is taking the values 5 through 9. Okay, so I'm splitting each stem up to a lower and an upper one. Now you do have to make sure the stems are equal. So you will always be using 0 to 4 and 5 to 9 as your kind of breakdowns for those. Now, what's the benefit to this? Well, the benefit is that now you can see the shape better. When you get too much data in a single stem, you start losing part of your shape. Okay, so notice this one right here, you can much better see the shape than you can in that one right here. So whenever you're making a stem plot, if you're noticing kind of a lot of data in a couple stems, start stem splitting to split up that data to make the shape easier to see. Okay? Another thing to know about stem plots is you can do back-to-back stem plots. So for back-to-back stem plots, notice they start in the center And then this one gets bigger as you work out that way and bigger as you work out that way. So as you're organizing your data in a back-to-back stem plot, using exactly the same stems, but now you're progressing outward, getting bigger, okay? Now, of course, notice they do have their key, which you always, always need. And now we want to compare the distributions. And again, in making comparisons, we need to make sure we're using SOCs. Shape, outlier, center, spread. All right, so spread. I'm going to use green for females. So for the spread for females, it looks like there's more values on the smaller values than there are in the larger values. Okay, so what that's going to mean is more data in the larger values than the smaller values. This is going to be skewed left. Okay, it's kind of trailing off towards the smaller values. For males, I'm going to do in blue. Males, to me, it looks roughly symmetric. Again, not perfect, but close enough, okay? There's no distinct trailing off in one direction or the either. Outliers, I don't really see outliers in either one. Okay, so I'm going to put none. I have no reason to believe that either one of these has outliers. All right, for center, so finding the median. Well, first, let's see how many kids there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 males. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 females. So 17 males, 22 females. So females, there's an even amount. So that means that we have to find in between the 11th and 12th data points, counting in order. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for females, it looks like their median is at 162. I need to average those two numbers. For males, if there's 17 data points, it's exactly the middle point. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is going to be the 9th data point. So there's 8 above it, 8 below it. So males are at 167. The spread, well, the spread for the females is 169 down to 152. Males are from 187 all the way up there down to 151. Okay, so notice I collected all of my thoughts together first. Now let's put them in sentences. So the male distribution is roughly symmetric, while the female distribution is slightly skewed. Whoops, I'm sorry, I wrote that wrong. This would not be to the right, this would be left. The males have a higher median, a 167 versus 162, and a larger range. Neither distribution has any obvious outliers. All right, so again, just putting whatever you've discovered back into full sentences and complete thoughts. That's what you're always going to be going for. All right, so thank you for joining me for this, and I look forward to seeing you back in class.